Okay, here are your notes for section 4.7, which gets us into isosceles and equilateral triangles. So if you remember, isosceles triangles have two congruent sides. So for it to be an isosceles triangle, we know that it has to have two congruent sides. For something to be an equilateral triangle, it needs to have three congruent sides. So in this isosceles triangle, just some vocabulary that we want to cover. Your vertex angle is going to be the included angle that is between the two congruent sides. The legs are the sides that are shown congruent. Your base would be the third side. And then the most important angles that I want you to focus on here are the base angles. Notice that your base angles are the angles attached to the actual base itself. Okay, and they are opposite of the legs. So if you have your leg here and you go opposite of that leg, it takes you to a base angle. This leg here will take you opposite to a base angle. So in an isosceles triangle, you have a vertex angle, which is the included angle between the two congruent legs. You have base angles, you have two legs, and a base. So when an isosceles triangle, so we're just putting these into definitions, fill in the blanks. When an isosceles triangle has exactly two congruent sides, these two sides are the legs. The angle formed by the legs is the vertex angle. The third side is the base of the isosceles triangle. And the two angles adjacent to the base are called base angles. So here are the theorems that you need to concern yourself with. The base angle theorem says if two sides of a triangle are congruent, then the angles opposite them are going to be congruent to each other. So if we had this as our triangle, with A being the vertex angle, B and C being the base angles, if we know that side AB is congruent to side AC, then the angle opposite of them, so the angle opposite of side AB is angle C, and the angle opposite of side AC is angle B. So those would be your base angles. So your base angles would be congruent to each other. So if you have two congruent sides, you're going to have two congruent angles. That's pretty much what we need to concern ourselves with. You just need to make sure you pick out the correct ones. The converse of the base angle theorem says if two angles of a triangle are congruent, then the sides opposite them will also be congruent. So if BC, our angle B, is congruent to angle C, then we know that the sides would then be congruent. So if I know that angle B is congruent to angle C, then the side AB would be congruent to side AC, right, which would be your legs. So those would be congruent to each other. So isosceles triangle, two congruent sides, two congruent angles. The corollary to the base angle theorem says if a triangle is equilateral, then it is equiangular. So remember, equilateral means all three sides are the same. Equiangular means all three angles are the same. So if all three sides are the same, then that means all three angles are the same. And if all three angles are the same, that means each of these angles would be 60 degrees. Okay. So here are our examples. In triangle PQR, side PQ is congruent to side QR. Name the congruent angles. So if I go opposite of QR, that's going to put me at angle P. Opposite of angle PQ, it puts me at angle R. So angle P is congruent to angle R. Would be your congruent angles. Now let's throw in some numbers. Find the measures of angle X and Z. So Y is the vertex angle. Down here would be my base angles. My base angles are going to be the same, right? So we could do it algebraically. I could make this be an unknown X and this be an unknown X, and I know that all three of these angles should add up to 180 degrees. So we could do 50 plus X equals 180. 50 plus 2x equals 180. Subtracting 50 gets us 130. Dividing by 2 gets us 65. Right, so the measure of angle X would be equal to 65 degrees, and the measure of angle Z would also be equal to 65 degrees. Or you could just do 180 minus 50 and then cut it in half if you didn't want to have to do it out algebraically. Either of those would get you to the 65 degrees. Number 3, find the values of x and y in the diagram. So notice here on the left, we have 3 congruent angles, which means we're going to have 3 congruent side lengths. So since that left side is 7, all the rest are going to be 7. Notice on the triangle to the right, we have 2 congruent angles, which makes those my base angles, which makes this leg congruent to this leg. So if this leg is 7, then we know that this leg also needs to be 7. So there's your equation to solve for y. Subtracting 4 gets us y is equal to 3. So we got x is equal to 7 and y is equal to 3. And I think that concludes our notes. There it is. Quick and easy.